In this video, I'm going to find the gradient of the function phi of xy is equals to x squared minus 4y squared at the point 2, 4, and the gradient of the function phi of xyz is equals to x squared z squared multiplied by sine of 4y at the point minus 2 pi over 3, 1. So I'll start by looking at the first one there, phi of xy. What we are given here, this scalar function is a function of two variables. So for our grad, it will be the grad with two components. So we'd have that our grad phi is equals to the partial derivative of phi with respect to xi plus the partial derivative of phi with respect to yj. So I can just write my grad phi there, the one with two components. And then I go on and input the phi that we have here, put it into this equation so that we have the partial derivative of x squared minus 4y squared with respect to xi plus the partial derivative of x squared minus 4y squared with respect to yj. So I will now go on and evaluate those partial derivatives. So if we are looking at the first one here, that partial derivative with respect to x, it will give us a 2x. So for that part, will remain with 2xi. Then for this part here, differentiating with respect to y, treating x as if it's a constant, our result there will give us minus 8y. So we would have minus 8yj. But our question is asking us to evaluate the gradient at the point 2, 4. So at the point 2, 4, we are saying x equals to 2 and y equals to 4. So we substitute these values into this expression here so that we have our grad phi at the point 2, 4 is equals to 2 times 2i minus 8 times 4j. And that will simplify to 4i minus 32j. So what you are having there, that's the gradient of the given function at the point 2, 4. I now move on to the next question, the one where we're having phi of xyz is equals to x squared multiplied by z squared multiplied by sine of 4y at the point minus 2 pi over 3, 1. The function that we are given here has three variables. So our grad phi is the one that would have three components. So we'd have our grad phi is equals to the partial derivative of phi with respect to xi plus the partial derivative of phi with respect to yj plus the partial derivative of phi with respect to zk. So I'll just write my grad phi there, the one with three components, and then put the function that we are given here, x squared z squared sine of 4y, so that we have our grad is the partial derivative of the phi there with respect to x, then with respect to y, then with respect to z, after substituting the phi that we are given. So I will now go on and evaluate those partial derivatives, starting with this one here, differentiating with respect to x, treating y and z as if they are constants. So if I differentiate there with respect to x, what I'll get is 2x z squared multiplied by sine of 4y I now move on to the next part, differentiating here with respect to y, treating x and z as if they are constants. So the result that we'll get there is 4x squared multiplied by z squared multiplied by cosine of 4yj. I now move on to the next one, and this partial derivative here, differentiate with respect to z, treating x and y as if they are constants. Our result that we'll get there is 2x squared multiplied by z multiplied by sine of 4yk. So I will now go on to evaluate now that gradient at the point minus 2 pi over 3, 1. So what you are saying there at that point is x is equals to minus 2, y is equals to pi over 3, and z is equals to 1. So if I substitute those values, what we'll get there is 2 times minus 2 multiplied by 1 squared multiplied by sine of 4 times pi over 3i plus 4 times minus 2 squared times 1 squared times cosine of 4 times pi over 3j plus 2 times minus 2 squared times 1 times sine of 4 times pi over 3k. I can now go on and look at this part here so that we try to simplify there. The 2 times minus 2, it gives us a minus 4, then minus 4 times the 1 squared, it will be minus 4. So that expression there that I've highlighted, it simplifies to minus 4 sine of 4 pi over 3i. I then move on to the next part here, 4 times minus 2 squared. That will give us 4 times 4, that's a 16, then times 1. So we'd have 16 times cosine of 4 pi over 3 j. I move on to the next part here. We are now having 2 times minus 2 squared. That will give us 2 times 4, that's an 8, then times 1. So it's an 8. So we'd have 8 times sine of 4 pi over 3 k. So that's the gradient that we are having, but we can simplify it further since we know that sine of 4 pi over 3 is equals to minus root 3 over 2 and cosine of 4 pi over 3 is minus a half. So if we substitute these values into our expression here, our result will be minus 4 times minus root 3 over 2i plus 16 times minus 1 over 2j plus 8 times minus root 3 over 2k. And that expression will simplify to 2 root 3i minus 8j minus 4 root 3k. So that's the gradient of the given function at the point minus 2 pi over 3, 1.